Okay, Sigma Workbook, page 151, number 5, 6 and 7. So number 5 reads, a binomial graph has a skew to the left. So it's skewed to the left. Let's put trials at 20, shall we? So skewed to the left. Oh, skewed to the left is that way, isn't it? It's very confusing. There's skewed to the left. What can you say about the value of pi? So when it's symmetrical, the probability of success equals the probability of failure. To get skewed to the left, probability has to be greater than 0.5. Okay, because remember the tail is the skew. It's a bit confusing, the whole language thing. So what are we saying for the answer for that one? For number 5? What can you say about pi? Has to be greater than 0.5. Describe the conditions under which a binomial distribution is bimodal. Okay, is that bimodal? No. How am I going to make it bimodal? I have a suspicion I'm going to have to make an odd number of trials. Oh, no. If I put that to 0.5, now I've got it. Okay? So if I go for an even number of trials, it's only got one mode. So the 0.5 gives me the symmetry, and the odd number gives me the two modes. So the condition is probability of 0.5, because any other probability is not going to give me that, and the trials have to be odd. Make sense? So that was number 6. Number 7, a curve drawn through the tops of each column in the binomial bar graph. It makes a good approximation to the normal distribution. Yes, we've noticed that. What can you say about the values of n and pi? So I think my best normal distribution is lots of trials and constant probability, because if I go not very many trials, that doesn't look very much like a normal distribution, does it? It doesn't. That looks more like a triangular, maybe. That looks like a triangular, sort of. Doesn't look so normal. So we really want to have a bigger number of trials and a constant probability, and then we get a beautifully normal graph. I shall now check if I'm right. Now look at the back of the book, look at the answers. There's some technical extra information for excellent students that you need to read.